Welcome to section 1.5 part 2. We're going to be talking about average rate of change and even and odd functions today. Average rate of change. When we're looking at a non-linear graph, so you can see on that given graph there's a curve. We can't find the slope because slope is for a line. Now what we could do is we can find the average rate of change, and that is going to be the slope of the secant line between any 2 points. And that's what average rate of change is. So for this function given in problem number 16, we're going to find the average rate of change for x cubed minus 3x. So we're going to use this function. The average rate of change is going to be f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. That's the equation we're going to use. So to do that, we're going to substitute into this x cubed minus 3x. So it's going to be f of x sub 2. So that's our f of 0 minus f of negative 2. So it's going to be 0 cubed minus 3 times 0 minus the entire quantity. So we're going to put a bracket. Negative 2 cubed minus 3 times negative 2, all divided by 0 minus negative 2. So that's going to be 0. We don't have to worry about that. So it's going to be a negative of negative 2 cubed, which is negative 8, and negative 3 times negative 2 is plus 6, over 2. So the opposite of negative 2 is positive 2 over 2. So the average rate of change is 1 for that function between those 2 points. Now if our points are 0 and 1, so it's going to be the average, of x sub 2 minus f of x sub 1 over x2 minus x1. So for this one, it's going to be f of 1 minus f of 0 over x2 minus x1, which is 1 minus 0. So substituting into the function now, it's going to be 1 cubed minus 3 times 1 minus the quantity of 0 cubed minus 3 times 0 over 1 minus 0, which is 1. 1 cubed is 1, minus 3, minus 0, over 1, so we're going to get negative 2 over 1, so the average rate of change is negative 2. It's really just substituting into the equation for the average rate of change, using the values and using the given function. We can do another couple examples. So the distance s in feet a moving car is from a stoplight is given by the function s of t equals 20t to the 3 halves, where t is the time in seconds. We're going to find the average speed of the car from. So here's what we're using. So remember, it's going to be f of x sub 2 minus f of x sub 1 over x2 minus x1. So it's going to be the f of 4 minus f of 0 over 4 minus 0. So it's going to be 20 times 4 to the 3 halves minus 20 times 0 to the 3 halves over 4. Now 20 times 4 to the 3 halves, when you type that in, you're going to get 160 minus 0 over 4. So the average rate of change is 40, and that's going to be in feet per second are the units for this. And then for part B, the average between 4 and 9 seconds. So it's going to be f of 9, that's the second point, minus f of 4 over 9 minus 4. So it's going to be 20 times 9 to the 3 halves minus 20 times 4 to the 3 halves, all divided by 5. 20 times 9 to the 3 halves is going to be 540 minus 160 over 5. So it's going to be 380 divided by 5. So that's going to be 76 feet per second. And that's average rate of change. It's finding the slope of the secant line between the 2 points. Next, even and odd functions. An even function is a function that is symmetric to the y-axis. So if a function is even, it's also going to be symmetric along that y-axis. If a function is odd, it's going to be symmetric to the origin. It's going to have that origin symmetry. Now I'll show you how we can find that using this. So once again, what we're going to do is we're going to put negative x in place of x and make sure that the functions are equal. So h of negative x equals negative x squared plus 1. So h of negative x equals x squared plus 1. H of negative x equals, and that's the same as h of x, so it equals h of x. When that's the case, it's an even function. Odd function has origin symmetry, so we're going to put negative x in. G of negative x equals negative x cubed minus negative x. So g of negative x equals, when you cube a negative, you get a negative. So negative x cubed, negative times negative is plus x. Now, if you notice, we can factor out a negative. So it's negative 1 times x cubed minus x. That's what g of negative x equals. So what that is, it's saying that g of negative x equals negative 1, and that's our original function in the parentheses. It equals negative 1 times g of x, and that's showing us that it's an odd function. It's odd if it's negative 1 times the original function when you substitute the negative x in place of x. Let's see some examples of this and do some more problems. So we're going to substitute negative x and we're going to determine if it's even, odd, or neither. They don't have to be even or odd. So f of negative x equals the opposite of negative x plus 2. So f of negative x equals x plus 2. That's not equal to our original function. If we factor out a negative, it gives us negative 1 times x minus 2. So it doesn't equal the original function. Oops, sorry, that's negative 1 times negative x minus 2. It doesn't equal original, and doesn't equal negative 1 times the original, so that is neither even or odd. Try number 19, f of negative x equals negative x to the 6th minus 2 times negative x to the 4th plus 2 times negative x squared. Negative to the 6th power is going to be a positive, so it's going to be x to the 6th minus 2, negative x to the 4th is x to the 4th plus 2, and negative x squared is just x squared. So that's our original function. So f of negative x equals f of x. Because of that, it's even. And also, keep in mind, it has y-axis symmetry. Any function that's even has y-axis symmetry. Number 20, we're just still doing the same thing. F of negative x equals negative 3 times negative x cubed plus 2 times negative x plus 1. So it's going to be negative x cubed is a negative times negative 3, so it's going to be a positive 3, x to the third, minus 2x plus 1. Now, we want to see, it's not equal to our original, so we know even is out. So we're going to factor out a negative 1. So it's going to be negative 1 times negative 3x cubed plus 2x minus 1. So that's f of negative x. It's really close, but because it's a negative 1 inside instead of a positive 1 right there, it's neither. It was almost odd, but it's not. It's neither. F of negative x equals negative x to the third minus 3 times negative x. When you cube that negative, you get a negative, so negative x cubed. Negative times a negative is a positive 3x. Once again, it's not even, but let's see if we can factor out a negative. So we factor out the negative 1, we get a positive x cubed minus a 3x in parentheses, and that is exactly what we had for f of x. So f of negative x equals negative 1 times f of x. And because of that, it's an odd function. And because it's an odd function, it has origin symmetry. Problem number 22. F of negative x equals 5 times negative x squared minus 2. So when you square a negative, you get a positive, so it's 5x squared and then minus 2. Exactly what we started off with, so f of negative x equals f of x, making this an even function. And once again, because it's even, it has y-axis symmetry. Number 23, f of negative x equals 2 times negative x squared minus negative x plus 1. Square the negative, you get a positive, so it's 2x squared plus x plus 1. Now we can look, it's not the same, so it's not even. Let's see if we can factor out a negative. You get a negative 2x, write that. You get a negative 2x squared, a minus x, and a minus 1. That is not what we start off with in the parentheses, so it is neither even or odd. Last two. Number 24, f of negative x equals the opposite of negative x squared plus 3. So when you square the negative, you get a positive times negative 1, so it's negative x squared plus 3. That is what we started off with, so f of negative x equals f of x. So that is an even function. Keep in mind, an even function has y-axis symmetry. And this one's a little bit weird because it has the absolute value bars, but let's just go through our normal process. Negative x, 2, negative x to the fourth minus the absolute value of negative x to the fourth plus 13. So you get f of negative x equals, when you raise a negative to the fourth power, you get a positive, so it's 2x to the fourth, minus, when you once again, raise that negative to the fourth power, you get the absolute value of x to the fourth, and then plus 13. So that, luckily enough, is our original. So f of x equals f of negative x. So that is even, and it has y-axis symmetry. And we're going to be exploring different types of graphs in the next lesson. Thank you.